Have you ever looked closely at a flower, a seashell, or even a pine cone and wondered why they look the way they do? They all seem to have these beautiful curving shapes. What if I told you that many of these shapes are not random at all? What if nature was following a secret mathematical code? Think about a walk in the park or a trip to the beach. You are surrounded by patterns, but they are often so common that we stop noticing them. A snail shell spirals in a perfect curl. The petals of a daisy are arranged in a neat circle. A fern uncurls in a predictable way. It almost seems like there is an invisible architect designing everything, from the smallest plant to the largest galaxy. This architect isn't a person. It's a set of rules, and the language it uses is mathematics. Today, we're going to learn how to read its secret code. The story begins with a simple sequence of numbers discovered by a man named Fibonacci a long, long time ago. It starts with 0 and 1. To get the next number in the pattern, you just add the last two numbers together. So 0 plus 1 is 1. Now our list is 0, 1, 1. Let's keep going. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. Then 8, 13, 21, and so on, forever. This is the Fibonacci sequence. It might seem like just a simple number game, but this pattern is hidden almost everywhere in the natural world. Let's start with flowers. Look at a lily. It has 3 petals. A buttercup has 5 petals. A delphinium has 8. Do those numbers sound familiar? 3, 5, 8. They are all numbers from the Fibonacci sequence. It's not always perfect, but the pattern is there. Now let's pick up a pine cone. Look at the scales on its surface. You'll notice they form spirals running up towards the top. If you count the spirals going in one direction, you might find 8 of them. If you count the spirals going in the other direction, you will likely find 13. 8 and 13, 2 neighboring numbers in the Fibonacci sequence, right there on a pine cone you could find in your backyard. The most amazing example might be the sunflower. The seeds in the center of a sunflower are arranged in 2 sets of spirals. There are spirals curving to the left and other spirals curving to the right. If you were to count them, you would find a pair of Fibonacci numbers. You might find 34 spirals in one direction and 55 in the other. Or on a really big sunflower, you could even find 89 and 144. So we have a sequence of numbers. But how does this number pattern create the beautiful spiral shapes we see? This is where another, even more mysterious number comes in. It's called the golden ratio. If you take any 2 neighboring numbers in the Fibonacci sequence, like 8 and 13, and divide the larger one by the smaller one, you get a special result. 13 divided by 8 is 1.625. If you take bigger numbers, like 55 divided by 34, you get 1.617. The further you go in the sequence, the closer this number gets to approximately 1.618, also known as the golden ratio. Now, imagine you have a set of squares whose sides are the lengths of the Fibonacci numbers. A 1 by 1 square, a 2x2, a 3x3, a 5x5, and so on. If you arrange these squares in a special way and draw an arc through the corners of each square, you create a perfect, elegant spiral. This shape is called the golden spiral, and it's the exact same shape you see when you look at a nautilus shell. The shell grows in a perfect spiral, getting bigger at a constant rate determined by the golden ratio. This spiral doesn't just appear in living things. We see it in the swirling arms of hurricanes and even in the shape of entire galaxies millions of light years away. So why? Why does nature love these numbers and this shape so much? Is it trying to be beautiful? The answer is much more practical. It's all about efficiency. For a plant, the goal is to arrange its leaves or seeds in the best possible way. It needs to pack them tightly, but also make sure each one gets enough sunlight and rain. Growing in a golden spiral pattern is the most efficient solution. It ensures there are no gaps and that new leaves don't block the old ones. Nature, through billions of years of trial and error, discovered that this mathematical pattern is the best way to grow and survive. It's not magic, it's simply the best solution to a problem. So the next time you are outside, don't just look at the world. See the math hidden inside it. Count the petals on a flower. Look for the spirals on a pineapple. You now have the key to unlock one of nature's biggest secrets. You have learned to read the code that is written into the world all around you. Once you start looking for it, you will see that the universe speaks in the language of numbers.